calling these, this is calling this 2.39, but it's just a supplementary lesson about coordinate plane transformations. This is about compositions. So the last supplementary lesson we did was about transformations in a coordinate plane. This lesson is about transformations of transformations in a coordinate plane. So looking at composition of coordinate geometry, in this launch example, and we'll do this one together, it says triangle ABC with vertices -1, 0, B has 4, 0, and C has points 2, 6. Is first translated by the rule xy becomes x minus 6, y minus 5. So let's do that first. So first we're going to plot our points. And our point A is -1, 0. B is 4, 0. And C is 2, 6. So A, B, and C. So here's what our original image looks like, and we're going to apply the rule xy becomes x minus 6, y minus 5. So on my coordinate plane, I'm going to move each point down, or I'm going to move each point to the left 6 units and down 5 units. So A is going to be to the left 6 units and down 5 units. And that becomes A prime. B, I'm going to do the same thing. I'm going to go to the left 6 units and down 5 units. And C, I'm going to go to the left 6 units and down 5 units. And then it says triangle A prime, B prime, C prime is translated by the rule xy becomes x plus 14, y plus 3. So I'm going to take my A, I'm going to go 14 units to the right. And I'm going to go, so here's 14 units to the right, and I'm going to go up 3 units. And that becomes A double prime. Same with B. I'm going to go 14 units to the right, and then I'm going to go up 3 units. And C, I'm going to go 14 units to the right, and up 3 units. And here's my image in green, A double prime, B double prime, C double prime. That's my double transformed image. And the question is, what single rule is equivalent to the composition rule of these 2 translations? Well, if I look at C, how many units did I go to the right? And how many units did I go horizontally, and how many units did I go vertically? That's going to be the same for all of these. So I ended up going to the right a total of 8 units, and I went down 2 units. So my rule that I could have used, instead of translating it once and then translating it again, the rule I could have used would have been x plus 8, y minus 2. So then to get this image back to its original image, so how do I get triangle A double prime B double prime C double prime back to triangle A, B, C? I would have to move X back 8 units, and I would have to move Y up 2 units. So this new key vocab term that we have is called composition, and that's applying a transformation to the image of the original figure. So here's our transformation. Here's our original image. First, I reflected this image to get this pink image, the reflection of the original. And then I translated the reflection to get this orange image, the translation of the reflection. This orange image is called my composition. So if I transform my original figure, then I transform the image, the result is a composition. So that is my orange part, that's my composition. In this next example, looking at triangle PQR with the vertices -5, 3, -3, 6, and -6, 5, we're first going to reflect that across the y-axis to create triangle P prime, Q prime, R prime, and then we're going to reflect that image over the line y equals 1 to create triangle P double prime, Q double prime, R double prime. So first we can think of a general rule that we have for reflecting across the y-axis, and that's xy becomes negative xy. So first let's do that with our points. So P becomes P prime. So -5, 3 becomes 5, 3. Q prime is 3, 6, and R prime is 6, 5. And then we can plot these points and look at our graph. After we've plotted our points, the next step is to reflect P prime, R prime, Q prime across the line y equals 1. So here's our line y equals 1. And we want to reflect these points across that line. So P, we want it to be the same distance from the line of reflection as its image. So right now it's 2 units away from the line of reflection, so we still want it to remain 2 units away. So that's P prime. R is 4 units away. And we want it to remain 4 units away. And Q is 5 units away. So it should remain 5 units away. So then you can finish filling out the table for P double prime, Q double prime, R double prime, and then we'll think of the general rule that gets from P to P prime, and Q to Q prime, and R to R prime. So looking at our points, to get from P prime to P double prime, we keep our X values the same, but our Y values are, if we were reflecting just strictly over the x-axis, our y values would be the opposite. But since we're reflecting over the y equals 1 line, we're going to add 2 because we want the points to be the same distance away from y equals 1. So if it's 3 points above y equals 1, it's going to be 3 points below y equals 1 now. So here are our double image points, P double prime, Q double prime, R double prime. And so the general rule we use to get from P prime to P double prime, or triangle PQR prime to PQR double prime triangle, is xy becomes x negative y plus 2. So the question is what is the general rule that gets PQR to P double prime, Q double prime, R double prime? And that would be, so first our x turns negative, so we're going to keep that negative x, and then our y turns negative, and we add 2. So in this last question was the single transformation rule xy becomes negative x, negative y, plus 2. That gets triangle PQR to triangle P double prime, Q double prime, R double prime. In this next example, instead of doing if you go back one slide, in the example that we just did, that general rule is similar to the rule negative x, negative y, which if you look at all of your rules, negative x, negative y is 180-degree rotation. So we're doing 180-degree rotation, but we're also shifting this instead of rotating it around the origin. It's also shifting. Okay, so in this next example, we're looking at the composition of a rotation and a reflection. So the first question is what happens, let's first reflect across the line y equals x. So here's our line y equals x. So the first question is to reflect DEF across the line y equals x to create D prime E prime F prime. So the first thing you want to know is that we're reflecting DEF across the y equals x axes. So a shortcut we have for that is xy becomes yx. So we can use that to get our points D prime, E prime, F prime. So we're just swapping the x and y coordinates. So we get 2, negative 4 for D prime, 0, negative 1 for F prime, for E prime, and 6, 0 for F prime. And then you could go ahead and plot those points. And at the right, you can see the image, D prime, E prime, F prime, reflected over the line y equals x. Now the next thing we want to do is we want to take our original triangle DEF and we want to rotate it 90 degrees clockwise about the origin to create D prime, E prime, F prime. And a rule that we have from our last lesson is rotating 90 degrees clockwise about the origin, xy becomes y negative x. So we can apply that rule to our original points, DEF, to create our image D double prime, E double prime, F double prime. And once you get your 3 points, D double prime is 2, 4, E double prime is 0, 1, F double prime is 6, 0. You can plot those points. And now you can see a second image of triangle DEF to be D double prime, E double prime, F double prime. And if you look at that, that's our 90-degree rotation of our original figure. And now the third thing it asks us to do is to take D double prime, E double prime, F double prime, and reflect it across the x-axis to create D triple prime, E triple prime, F triple prime. And the rule shortcut we have for this is to reflect triangle D double prime, E double prime, F double prime across the x-axis. We get xy becomes x negative y. So you can use that rule to figure your points for D triple prime, E triple prime, F triple prime, and then plot on your chart. And as you're plotting those points, you can find that E triple prime is the same as E prime, D triple prime is the same as D prime, and F triple prime is the same as F prime. And you can look at your chart too to draw the conclusion that these two are the same, these 2 points are the same, and these 2 points are the same. So you can gather then that to rotate triangle DEF 90 degrees clockwise and then reflect it across the x-axis is the same as reflecting it over the line y equals x. So lastly, there are a couple summarized questions. What's going to happen if you change the order in which the two lines of reflection are used? So if you reflect it over y equals 1 and then over the y-axis, as opposed to over the y-axis and then over y equals 1, the direction of your rotation is going to change. And then the second summarized question is, what will happen if the translation is followed by a reflection along a line in the direction of that translation? And we call this a glide reflection. So in this glide reflection, the orientation is shifted, but there's not a perfect reflection line since it was translated and then reflected along the same direction as the translation. So this new term, glide reflection, is what is the result of a reflection and then a translation. With this, you could still identify a line of reflection. In this extra example, try this one on your own. So you can draw any triangle and then translate your triangle using the transformation rule: xy becomes x minus 4, y plus 1. Then reflect this image across the x-axis. And then what single transformation rule can you get to get your original image to the original figure to the final image? And again, this is called a glide. This is called a glide reflection, where you're reflecting and translating the image. So come up with a single rule to go from your original figure to your final image. And then lastly, look at two single translation vectors that can replace the composition of these three translation vectors. So we're looking for one single translation vector that can replace all three of these. So from your beginning image to your final image. And then look at the single rotation that can replace the composition of these three rotations. And then lastly, just some food for thought, what's going to happen if the centers of rotation differ? So please try the extra example and the closing question on your own. And then next time I see you in class, we will go over and do some extra practice problems with these.